Today in class, we learned about 3 types of transformations, or in your Eureka book, we describe those as basic rigid motions. The first one was where we take an image or figure and we slide it to another location. And this is what is known as a translation. The second one is where we have a figure or an object that is turned, or we spin it. All right, and this we refer to as a rotation. The other one we talked about was when we flipped a figure or an image, and that is known as a reflection. So we have a translation, rotation, and a reflection. In this problem, we will want to know which one of those transformations we are using. So as you can see, it says to describe what you see in the diagram below. Use as much of the new vocabulary as you can. So if I have line segment BA and it looks like it has been moved or mapped down to line segment B by F or A by F, then I need to know what kind of transformation happened. But before we do that, let's look at what is this funky F parentheses B and F parentheses A. Well, the F represents the transformation. So I think we can see that in this case, the line segment was just moved straight down. It wasn't turned, it wasn't flipped. So we're going to call it a translation, all right? And oftentimes that translation is given a name. In this case, they've called it F. So this is translation F. So F parentheses A means that point A was mapped or moved to point F A, or what they say A by F by transformation F. So this F parentheses B simply means this is point B after it was translated by F from point B. Now, another way to write this in a way that I prefer would be calling it B prime, okay? So you have B, the original point, and B prime after it's translated, and this would be A prime. But it's important to know that if you see F and parentheses A, they're saying this is the new A, and it got here by being translated by translation F. So now that that's out of the way, what other observations can we make? So we have a translation that's going on. One thing is to look at the length of the line segments. Notice how they are the same length, okay? They are the same length. So when we translate something, the length doesn't change. Now there is a fancy way of saying that, and that's called distance preserving. And what they're saying is the distance between B and A is the same as the distance between B prime and A prime. So that distance does not change as a result of the translation. So if you can make those observations about a line segment during your homework, you will have done very well. Thank you for watching. Hopefully this helped your homework today.